This is the tutorial regarding solving equations algebraically. We are going to cover three main topics. First of all, linear equations, next quadratic equations, including the quadratic formula and the discriminant of a quadratic equation, and finally we'll talk about absolute value equations. Let's get started. First we'll discuss linear equations. An equation in one variable is a statement in which two expressions, at least one containing a variable, are equal. The expressions are called sides. So for example, in this equation, x plus 3 would be one side and the 8 would be another side of the equation. And since an equation is a statement, it may be true or false depending on the value of the variable. Unless otherwise restricted, the admissible values of the variable are those in the domain of the variable. Those admissible values of the variable result in a true statement and are called solutions or roots of the equation. So for example, in this equation here, the x plus 3 equals 8, the statement is true when x equals 5 and false for any other choice of x. Thus, 5 is the solution of the equation. We say that 5 satisfies the equation because when we substitute 5 for x, a true statement results. A linear equation in one variable is equivalent to an equation in the form of ax plus b equals 0, where a and b are real numbers and a does not equal 0. So as you can see, all of the equations here are satisfying the definition of a linear equation. Next, we're going to discuss quadratic equations. A quadratic equation is an equation written in the form of ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a does not equal 0. A quadratic equation written in the form such as this is said to be in standard form. Sometimes quadratic equations are called second-degree equations because you can see the left side of the polynomial here. We have a squared component, so it's of degree 2. Quadratic equations are easily solved by factoring. So if we're given an equation such as, for example, let's look at x squared equals 12 minus x. We first put the equation in standard form by adding x minus 12 to each side. So when we do that, we would have x squared plus x minus 12 equals 0. The left side of the equation can now be factored as x plus 4 times x minus 3 equals 0. And then by the zero product property, we have x plus 4 equals 0 or x minus 3 equals 0. So our solutions are x equals negative 4 or x equals 3. So we say that the solution set is negative 4, 3. Quadratic equations can also be solved by using the quadratic formula. It's basically just an extension of what we saw in the last slide. Basically, we had the standard form of a quadratic equation as ax squared plus bx plus c equal to 0 when a does not equal 0. And if we go ahead and solve for x, what we get is this form of the quadratic equation. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, this is an interesting quantity right here, the b squared plus 4ac, because that quantity is called the discriminant of the quadratic equation. The discriminant is important because that portion, the b squared minus 4ac, tells us whether the equation has any real solutions. It also tells us how many solutions there are. So as you can see, if b squared minus 4ac is greater than 0, we know there are two unequal real solutions. If b squared minus 4ac, the discriminant, is equal to 0, there is a repeated real solution, a root of multiplicity 2. And finally, if the b squared minus 4ac component, the discriminant, is less than 0, there is no real solution. Let's take a look at an example and see how the discriminant plays into the equation. Let's take the equation, for example, 3x squared minus 5x plus 1 equals 0. You can see we have the equation in standard form. We have the ax squared plus bx plus c equals 0 form. So we have 3, 5, 1. we can go ahead and see that A equals 3, B equals -5, and C equals 1. So when we know those values, we plug them into the discriminant, and we evaluate the discriminant as b squared minus 4ac. We would take -5 squared minus 4 times 3 times 1, which would equal 25, minus 12, which would equal 13. So since the discriminant b squared minus 4ac is greater than 0, we know there are two real solutions. Next, we're going to discuss equations involving absolute value. If a is a positive real number, and if u is any algebraic expression, then the absolute value of u equals a is equivalent to u equals a or u equals -a. Let's go ahead and look at the following example. We have the absolute value of x plus 4 equals 13. So when we're given that equation, we basically know two things. We know that either x plus 4 equals 13 or x plus 4 equals -13. So if we go ahead and solve for x, we have x equals 9 on this side, or x equals -17. So that's our solution set, -17 and 9.